Okay, now welcome back to my channel, and today we have a little difficulty, right? Just a small peculiarity. Um, well, pretty often I do just a couple of tasks from my tasks list given to me by AI, but today we're going to work with matrices, and it looks like the tasks began to become harder. So today we will work with exclusively one particular task AI gave me. Now without further ado, let's start. So, number 7, we need to create a program for working with metrics, lists of lists in brackets. I guess that this task is not that hard from the perspective of programming, but when it comes to math, it can be a little bit tricky. So I did my own research, and I've prepared a cheat sheet here explaining all the tasks I need to realize in here. So we have an explanation how to do addition and substitution and multiplication. There is always one possible option to do with matrix besides transposing. This is some kind of a division, but it's not a division. It is a multiplication to the reverse matrix. But to reverse the matrix, we need to do lots of more stuff. And at the end of the day, we are here working with programming, not math. And moreover, there are already are some libraries to work with matrix, so I'm not really sure that we need to waste our time on that. Now, when it comes to our today's program, first of all, what do we need? As AI hinted me, matrix basically is a list of lists, right? So, what are we going to do? First of all, we need to find out how our user is going to input our matrices. In here is going to be pretty tough, as we need to ask our user to input the list of lists and make sure that everything will be interpreted correctly. Now, matrix is some kind of a table, right? So it's like star minus 4, 3, and the second line 1, 5 minus 6. Oh no, let's be Jesus Christ. Something like that. And this is one matrix with the sizes 3 to 4. So we have 3 columns, so 3 elements in the line basically, and 4 lines, 4 elements in our biggest massive. How are we going to interpret it? We can just pretend that this is the one list. Each line is a list that lies down as an element in another bigger list. So basically, what it is, it's just a list of lists. And this is going to be our variable m. Of course, it won't work like that, yeah. So, now we need to ask our we need to keep asking, actually. We need to keep asking our user to input something. So we will have two variables. One is going to be m1, right? And the other one will be m2. We will not give them any values beforehand. So now and we need one more variable. This is a Boolean type. And now, while done equals to false, we keep asking our user input the line of the matrix. When we have it, we need to line equals to line dot split, and we're going to split by spaces. Then for each element we're going to L equals to int L. So we remember that everything we input is just a string. It's just a text, it can't be counted. So first of all, we need to make up our string into the list. But this is going to be the list of strings once again. So in order to avoid that, we need to convert them from string to integer. And after our user is finished with filling up the last line. Oh yeah, and here of course we need to m1, yeah, we need to make it lists first of all, just for us to be able to do all the methods that we can do with lists. Dot append to add, right? So we need to add it. Yeah, I guess yes. Append line. Yes, but how do we know that the input is over? Well, if line, so everything that has been input right here, right? If it is equal to done, then done will change its value to true, and we basically break. It's a little bit overcomplicated over here because we have like the double check. That is not good. Like we have one way to escape this cycle and we have another way, but it's okay. I wasn't sure that it's gonna work. So we've done with our first matrix, and now we need to never do it like this. Of the second, and here first, and here it's going to be M2. Never do that, as pretty often it shows that it's a very bad code if you have lots of repetitions in your code. But in this case, to avoid it, we would need to unite both our matrices into the list, and then start the cycle for each element, so for each matrix basically, of this list, and that would be just over complicated. And it's not too much here, just two matrices, so we don't need to work with lots of matrices at the same time, which is pretty good. So, and here we are. Here there are our two matrices, hopefully. Now, we have some constraints to mention before we are able to go further. So, print what operation do you require? One, addition. Two, substitution. Three, multiplication. Now, no, it's not going to be print, it's going to be operation equals to, and this is not print, that is an input. That is an input. And after that, I would like to change the line as well in here, right? So, okay. Now, if operation equals to 1, not like this, because everything we input we have in a string format. If we add something, right? What should we do? Addition and substitution are only possible for the same size matrices. So the number of the rows and columns, lines and columns, should be the same. So in this case, we need to check it. We check. When we check, it's mostly always if. Or almost always, sorry. So, if len of m1, what is len? It's actually the number of elements in a list. And here our main list is the list of lines, so we're checking the columns. equals to len of m2 and len. Now we need to check the length of lines. How do we do that? We check the length of any line of the matrix. M1 0 equals to len M2 0, the first element. In this case, we do the operation, right? So we do what? For E in range len of M1 and for J in range len M1 doesn't really matter, 0 for each element, right? So we need and we need no, and we need our result matrix. Our result matrix is going to be here. So what should we do? We should make a line that is no, actually, yeah, here we need element. Let it be L. Element equals to M1 E J plus M2 IJ. It's going to be the same. Okay. So we actually add M1 element from the first line, from the first row, column, sorry, to the element with the same index in the second matrix. Okay, we did it. Now, when we have it, we need to add it to somewhere, right? So basically, in here, I would say that in this, we will be able to make up a line that's gonna be an empty list, and here line dot append the element. After that, when we finish it with one line, we add this line to our result matrix. So result dot append line. Sorry, I was buffering. Well, sounds like okay. Otherwise, else the else print impossible operation, and the only thing when the operation is impossible in this case is when uh, let's say the sizes of M1 and M2 do not find match, which means that these matrices have different sizes. Okay, we are done with the addition. Now you understand why I said that today we're going to do just one task. Now, elif operation equals to 2. No, 2. Then basically the same thing as those two operations are extremely similar to each other, with one little adjustments here. Ta-da! Oh no, and in here we need to print the result, of course. Yeah. Then we need to find out how to print our matrix. So for L in result print L, I guess, and we're gonna copy this as well. Sounds nice. Oh no. And then when it comes much trickier, elif operation. No, there is no column over here. Elif operation equals to 3. Our multiplication. Ho, ho, ho. Now here, if it's going to be different, why? Oh my god, so much code over here. Fun. Multiplication is only possible when the length of the line of the first matrix is equal to the length of the column of the second, or it's a number. Wonderful, huh? Let's just erase that really quickly. Oh no. No. We will leave it and you'll see further. Okay. So, how are we going to do that? If the length of the line is the length of one element in the matrix, so if m1 slash 0 bracket 0, the line of it, make the size of, so is equal to the length of The second matrix is column. Basically, the column is the number of lines of the elements, so the length of this or this thing, right? And in this case, we're going to multiplicate it as a matrix. For that, what should we do? Each element of the result is a sum of multiplications of first matrix elements line and second matrix elements column. Any ideas what it means? Let's try anyway. First matrix elements line. So in the first line. Okay, so we should multiplicate the corresponding line to the same column. Okay. Let's try doing it. For E in range, where we will have to go through each element anyway. So it's basically the same as before. No. One. And not. No. Anyway, we will do it for each element of the first matrix, so it should be fine here. When it comes to the element, it is equal to it's gonna be the sum of the multiplications, right? How do we do that? It's gonna be so many cycles. I'll be based down in comments. Okay, basically, here we have the basic structure to work with each element of the first matrix. And be sure you can't change the order when you multiplicate the matrices. So A multiplied to B is not equal to B multiplied to A when it comes to matrices. So the order is very important here. Let's try. For each element, we need to go to another cycle. K in range. Oh, len m1 doesn't really matter. They're all the same. Why it's 9? It's not. There is no 9 over here. So what do we do? It's gonna be Yeah, the element is going to be inside of this cycle. Just for now, it should be 0. It's just like by default. So, and here we are going to do it. So, it's gonna be mm-hmm. Nuh-uh. Mm-mm. Oh yeah. Okay, let it be so. Let it be so. Part equals to it's gonna be first line to the first I line to the J to the J. Where does the J figure then? I'm a little bit confused. We need some visualization in here. So we have the matrix 1. Please let it be, let's see, 18. 1, 2, 3, 4. No, let it even be like this. 11, 12, 13. I said 13, and it's going to be in the first row anyway, if you want it or not. Then it's going to be 21, 22, 23. Right, and we need to multiply that to 1 2 3. Gonna be like this, and then here we add 21. Oh no, 12, sorry. Our result matrix is going to be R11 is equal to the first thing what's gonna happen. So we see, yeah, so the number of the length of the line of the first matrix is the same as the number of columns in the second matrix. So theoretically we should be able to check it. In our case, when it comes to our program, the length of M1 is number of columns, right? Where is it? This is our I. and this is our J. And our K is nothing, it's just the same as J. Fine. Okay. Anyway, our result is love paint. Yeah. It's gonna be it's better to switch them, right? I guess so. It's gonna be 11 multiplied M11 plus then 12 multiplied M21 plus 16 multiplied M31. It's gonna be our first element, right? So what we're basically looking through, this is equal to our J, and this is equal, so basically it's our K, right? And this is to our, this is equal to I, but it's not I. Okay, with the first we got it. Now when it comes to R 1, 2, what are we going to do? Oh, are we going to just, okay, I think I'm starting to understand. So you see, Ij is equal to Ji. So it's gonna be 11 multiplied M12 plus 12 plus, I said, multiplied M22 plus 13 multiplied M32, right? So we have our first row, and now we need one more just to understand that everything is okay. So our R, well, but what are we going to do with our 13? No, something is definitely wrong here. How are we doing our R13? To which, where here are we going to do that? Let's check this mess really quick. It's not gonna. No. This is these are the determinants, something like that. Okay. Here we have it. So this to this plus this to this plus this to this in here. Oh, so there is not gonna. Oh, shoo. Okay. So it's gonna be 2 for 2. We won't have it in here. We need to restrict this in our code, really. Otherwise, in here, it's gonna be this to this plus this to this. True. In here is gonna be this to this plus this to this. It's true, and then it's gonna be something. This to this plus this to this. Okay. So so complicated. Oh my god. Okay, in here I understood, but when it comes to the opposite, let's just try it out. The parts will be equal to, we need to multiply the line to the column of the second one. Right now. Hopefully so. And each for each element, the element's gonna be the part is going to be M1 of the corresponding line of the corresponding okay. Yes. Multiplied to M2 of the of the J I, and then elements equals to elements plus part. Is it gonna be like this? I feel confused really. Okay. In this case, this video from now on is officially too long. So what I'm gonna do, I'm gonna figure it out a little bit offset, right, or off screen, and we'll come back with the final result. So I'll make sure to upload it as quickly as possible. And as for now, thank you very much for watching this video. You see, we're struggling, but we're still on our way. Never give up. So, see you soon. Bye.